Hey there, algebra students. It's time for lesson 1-5. It's about equations, and maybe we'll even hit on some inequalities as well. Our joke for the day is, what is an owl's favorite subject? And the answer is algebra. I know, funny jokes. It's a good one. All right, here's your answers for lesson 1-4, the distributive property. Check your answers, pause the video if you need to. And remember, if you need help with any of these problems, just shoot me a message or an email, and I will help you out. All right, let's move into the lesson. Today, the lesson is about equations. So you're going to see some problems like this. Find the solution for the equation 4a plus 7 equals 23 if the replacement set is 2, 3, 4, and 5. That means that 2, 3, 4, and 5 are the numbers that we're plugging in to see if they work in this equation or not. So let's start with 2. When I do these problems, I like to make a nice table to organize myself. A is 2, which means wherever I see an A, I'm going to plug in a 2. 4 times 2 plus 7. Well, 4 times 2 is 8, and 8 plus 7 is 15. Does that equal 23? False. Let's move on to the next one, number 3. Again, wherever I see the A, I'm going to put a 3. 4 times 3 plus 7. 4 times 3 is 12. 12 and 7 is 19. Does that equal 23? False. It does not. So we move on to the next one, the 4. Plug it in for the A. 4 times 4 plus 7. That is 16 plus 7. That's 23. Ah, it works. Excellent. Now on these problems, you don't go until you stop or until you find the correct answer. You have to go through every single one of them. So let's go ahead and try 5. 4 times 5 plus 7. 4 times 5 is 20. 20 plus 7 is 27. And no, that does not work. It is false. So your answer for these types of problems is your table, all organized with your work. Perfect. Then we've got another type of problem. You need to solve for a variable. Luckily, this variable is already by itself. So really, this is an order of operations problem. I'm going to deal with the top first. In the parentheses, 8 plus 2 is 10. And then I do 5 times 10, which is 50. Then I'm going to work with the bottom. Parentheses first, so I have 18 minus 5 minus 3 is 2 cubed. 2 cubed is like 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. 18 minus 8 is 10. 50 was my numerator, 10 was my denominator. And remember that fraction bar actually means to divide. So 50 divided by 10 is 5, and that is what k is equal to. So in your assignment, you're going to have some problems like that. Just do the order of operations like you've been doing, and you will be successful. But sometimes the variable or the letter is not going to be by itself, and we have to get it there. Remember, in these types of problems, sometimes it's helpful to draw the railroad tracks or the Nile. Let's do order of operations inside the parentheses. 4 squared is 16. 4 times 4 minus 10. 7 minus all of that plus n equals 10. 16 minus 10 is 6, so I have 7 minus 6 plus n equals 10. 7 minus 6 is 1 plus n. That equals 10, and it's getting more and more familiar, or more and more. See, I want to get the n by itself. If I cover up the n, I realize that adding 1 is extra, so I get rid of adding by 1, by subtracting by 1. 1 minus 1 is nothing. 10 minus 1 is 9. So my answer is n equals 9. this problem. We're still trying to get n by itself, but it looks like we've got a distributive property to deal with as well. You could do the distributive property, or we can do inside the parentheses first. N times 5 plus 6 equals 5n plus 10 minus 3 is 7. And n times 5, we actually like to write the number first. I want to get all the n's on one side. Doesn't matter which side, so I'm going to subtract 5n from both sides. 5n minus 5n is nothing, leaving me with 6 on that side. 5n minus 5 is nothing, leaving me with 7. Wait a minute. I've lost my variables, I've lost my letters, and I'm here with 6 equals 7. 6 does not equal 7. That is false. When you are working through problems like this and you come to something that is not true, you lose your letters, your variables, and you come to something that's not true, the answer is no solution. You can either write the words like this, or you can put a circle with a line through it. That also means no solution. So when you lose your variables and you come up with a false statement, your answer is no solution, or circle with a line through it. There's one other case we want to look at, and that's called an identity. An equation that is true for every value of the variable is called an identity. And you can tell something is an identity by simplifying. I'll show you. 2 times 5 is 10. 10 minus 8 times 3h plus 6. 10 minus 8 is 2 times 3h plus 6. Looks like the UPS driver, so I'm going to stop at both of them. 2 times 3h is 6h. 2 times 6 is 12. That's the left side of the equation. Now we'll do the right side. Over here, inside the parentheses, 2h and 1h can be combined. So we have 3h plus 6, and the 2 is behind it. That 2 looks like a UPS driver. Stop at all the houses. 2 times 3h is 6h. 6 times 2 is 12. Look at that. 6h plus 12 and 6h plus 12. Yeah, that's the same on both sides. It is definitely equal. When you get something that is exactly the same on both sides, that's equal, that's known as the identity. That means you can put any number, any value in for h, and it will always work. So when you get something that it's the same, exactly the same on both sides, there is infinite solutions. Infinite solutions. And so that's what your answer would be. Or you could write the infinity symbol and solutions. Either one of those is an acceptable answer when you've got the same thing on both sides of the equations. That's an identity. And in your assignment, you'll probably come across a nice word problem or two as well. A four-wheel drive tour of Canyon de Chelly National Monument in Arizona costs $45 for the first vehicle and $15 for each additional vehicle. How many vehicles can the Velo family take if they want to spend no more than $110 for their tour? So first we need to put this into a mathematical sentence. We know the first vehicle is $45. And it costs $15 for any extra vehicles. And we know that the $110 is their maximum. So whatever this is, it should be less than or equal to it. There's our sentence. Now we may want to do some guessing and checking. Let's try 3 vehicles. Well, it's $45 for the first one. And if there's 3 vehicles, that means there's 2 more. Is that going to be less than or equal to 110? 45 plus 30 is 75. Yeah, that works. 75 is equal to 110. Or is less than or equal to 110. But can we do more? Maybe this time let's try 5 vehicles. 45 for the first one. Then we added 15 for each of the extra ones. If there's 1 here, that means there's 4 extra vehicles. Is that going to be less than or equal to $110? 15 times 4 is 60. 45 and 60 is 105. Yes, that is cheaper than $110. If we had 1 more vehicle, that's going to add 15 to it. 120, that would be too much. So 5 vehicles is the most that they can do. Perfect. All right, here is your assignment. Ooh, it's a little bit hard to read. Page 34, problems 12 through 30, the evens. So 12, 14, 16, 18, 20, 22, and so forth. Then do 34, 65, and 67. Have a great day, you guys. We'll catch you later.